You're seeking to set a null hypothesis and to reject that to show statistical significance. The p-value is the probability that the null hypothesis is true. That's what it's actually measuring. And the smaller the p-value, the more significant you would say the result is. Don't automatically assume that a non-significant result proves the null hypothesis, proves that your groups are the same. So what are the influences on statistical significance? It's more likely when the different, of course, if you've got a big difference between the groups, as we had between those case curves and the normal curves, then the differences you're going to get more likely to have significance. If you've got a smaller variability in the data, then it's easier to show statistical significance. And even if you've got high variability, if you've got a really large sample, then you still might get statistical significance. So the bigger the sample, the more likely you are to detect a difference. In fact, that's more or less what I've said. Small sample, you might not get a significant difference and there's a risk of missing an important result. Large sample, conversely, you might get a significant difference, but it might not be very important to you from the scientific point of view. So that's where I think somebody asked earlier about what sample size do you use, and we will be looking at sample size calculation, so you get what you think is going to be just enough data to detect important differences, but not so much that you're picking up non-important ones as statistically significant.